Started here. Good morning, everybody. My name is Austin Buckles. I'm sales manager at DB Sales. This is another one of our monthly webinars that we do on various topics. This week, we have US Pump Corp talking about control and pump system advantages. Today, we'll be speaking as Kevan Woodworth and Mike Kilcrece. And I wanted to remind everyone, if you do have a question about anything that we discuss, feel free to write that in the Q&A box at the bottom of the window. One of the panelists will be able to answer it for you. And again, if there's anything a question you have after the presentation, you can ask it at that point as well. Our contact information is available to most of the individuals that have joined us today. But with that, I'll hand it over to Mike Kilcrece and we'll begin the presentation. Thank you very much.
Hi, everyone. Thanks for participating today. We'll try and give you some information about some updates on new controls with our sump and sewage, and also with the booster station that we're marketing throughout the country. Tell you a little bit about US Pump. We've been in business about 18 years, and we started out in New York City and kind of pushed the company west. Our manufacturing facilities in St. Louis and our corporate offices are in New York City. So without further ado, I'm going to go forward here. Kevan Woodworth is also on the phone. He's traveling today. So if you do have a question, I will see it and try to get Kevan to jump in if he can.
Yeah, I'm here. So whatever's needed.
Okay. All right. Guys, our product line is called the iBoost and the iLevel. The iBoost is, of course, our constant pressure booster system, which is an NSF certified system through UL. And of course, the panel and controls are also UL listed and UL 508A. We can also, do different levels of control panels if needed. We're good with the custom systems. We have our own, custom engineering shop, and we do all of our fabrication in-house. So, it's a big advantage if you're a booster manufacturer to be able to manufacture and fabricate your own parts and pieces in your own facility. Components for the pumps, we typically use all the brand names that you guys are familiar with. We like Grundfos, vertical multi-stage, Gould's as well. It just depends on the job and the customer sometimes for the application. For our end suction systems, we use the Scott pump, which is part of the Velo conglomerate, and then also Paco pumps from Grundfos. As far as the control components, we try to make our systems as easy to understand as possible. Everything is as you see it there in the panel, pretty easy to understand. You've got your VFD drives. We like to put our VFD drives, if possible, inside the NEMA 4 enclosure, and that's just simply because of the fact that we feel that there's added protection there, and it also has less chance of someone messing with the settings and things like that. Every system has a hexagonal enclosure, which is basically a metal enclosure. We can use the NEMA 4X, which is stainless steel, and then also the NEMA 4X plastic enclosure for some models of our sump and sewage systems. But for the most part, we build all of our own panels, and we make them with a NEMA 4 steel enclosure. Our sensors on there are also WICA controls. So just that we have also the transducers on everyone. I jumped past a little bit here. Sorry. Components, as far as your wetted and structural, our manifolds are usually Schedule 10 304 stainless tube. And then we can jump up to Schedule 40 if there's a need for that. But typically your Schedule 10, which is rated to 600 PSI, is probably adequate for most systems. We do use stainless steel. We don't use copper on our headers. Our headers are rated at either, your 150 pound or your 300 pound, depending on the pressure in the system. We use neck welds for elbows and spool pieces, and it's pretty good construction, as you can see by the picture there. That's pretty much an average system that you'll see that comes out of our shop there on the picture. As far as shutoff valves, we use the Bonomi lug style, which has your 316 disc and it's NSF 61372. Your check valves are your Flowmatic. Those are your wafer checks. We do not really use a threaded check valve very often. We like the fact that our check valves are, the lug style, and they're just a little bit easier to work on. They're a little bit easier to service if you have to do a change on the unit than having a threaded connection. If you've ever seen the threaded connections in the field on smaller units, one of the biggest problems is if you do a repair, or you do a pump replacement, you have an issue usually with balancing your headers and balancing all your elbows in the same position that they were before you took the pump off. So for ease of service, we like to use the stainless lug style connections and the flange connections on our branches. We also have a unit now that we're making that also has a roll groove end, and that does save some expense, and some of our customers prefer that over the flanged ends, which we can also do. So as far as our key features and the touchscreen, we're using a Siemens touchscreen. These are your three basic screens for the booster. You've got your main screen on the left-hand side here, and this is actually showing you, with a tank suction, and it's giving you basically your controls for auto or running in hand, sorry. And then right here, it shows you in that blue section there, your pressure that you're running at. And then this is your PID loop screen right here. On the alarms, we have the standard alarms, which is basically, your low suction, your no flow alarm, your high suction, and also the alarm has a strobe on top of the panel. And we also have the Modbus integration if you need that. So on with your building communications, we're pretty good about that. We can pretty much match any customer's needs there. So you just have to give us a heads up in terms of what you're using there. We like to use the Modbus just because it's easier and it's a little less expensive. There's obviously a couple different settings, and Kevin, I don't know if you want to talk about that for a sec, as far as how we interface with the building.
Yeah, so we can actually do three different suction inputs, all from the same controller. The only thing that would be different from that point would be the sensor. So we could use a typical, city main where we're running off of a higher PSI. We can run off of a flow switch, which is typically going to be done using a tank, but we can also use a tank and actually act more like a permissive using a submersible transducer. So the submersible will actually show you the level in the tank, and basically you put a set point in there to make sure that the input is flooded, and the pump will basically say, over this value I can run. Once I go under that value, I can't run. And that'll basically tell be your low suction protection.
And then about the Modbus, if you could get into that just a bit.
Yeah, so we can interface. So our standard is Modbus. So, we can interface to basically any controls using that method. I know a lot of people tend to use BACnet. We can still go that route. It would just, regardless, we would need an interpreter between the BACnet and the Modbus. But we can any type of BMS we can connect to.
Okay. Down here is so your top example would be your tank feed, and then this is just your setting screen, pretty simple on the right hand side, and then the bottom, this would be if you're running the pumps in hand. So you can see that you can set it by percentage, basically, And then, you know, you're running the pump. So let's just say you're having a problem with the system. Maybe you need to test the system. Maybe you got a pump out and you don't have the ability at that moment to cover your pressure needs. With the auto control, you can set it right in front of it, and you can leave it on, you know, whatever percentage you'd like to run it at, and then it'll give you your PSI readout on the other side there. Okay, your add-ons. Basically, you know, again, we're a custom shop, and the advantage to a booster company that has, you know, a custom shop is depending on the engineer's needs, depending on the regional needs. Like you guys are out in California, you have a couple more regulations than some of the other states, and you know, we can make those changes to our design. Mechanical bypass. You can do a bypass mode for the motor starters, not run off the drives if you want to. We don't recommend that, just simply because today with our new technology, our systems run off a program in the PLC. The drives are really there to throw themselves on a grenade, you know, in the event of a high voltage situation or something, you know, that would affect the electrical circuitry there. So the drive will protect the motor and keep you from having to purchase, you know, a brand new motor as well as a drive if a drive were to go out. On the ABBs, everybody's pretty familiar with them, so we like to stick with them. We do custom drive units, like we did one for Northern Illinois University recently with, I think it was Toshiba drives, and the reason we did that for them is because that particular customer, all of their personnel on the whole campus had been trained with the Toshiba drives, so we accommodated them and wrote a program for that. As far as you know, any of the other things that you guys might look into, I mean, a flow meter, your BMS like we talked about, your back net. If you wanted an upgraded panel with, let's just say, air conditioning, and it's an exterior location, we can do, you know, the 4X stainless steel with an air conditioner or a heater on there, and that keeps your, you know, your panel at whatever temperature that you would like it at. But we try to recommend something, you know, around 100 degrees, no hotter than that. Although the new drives are all rated for much higher temperatures, that can actually go up to about 140 degrees and still maintain operation. So that's another reason we kind of use the ABB. Moving along here. As far as serviceability, I started a little bit on that. You know, the flange connection with the no threads prevents leaks. If someone has to adjust something, change a valve, change a pump, change a motor, you're pretty much better off, we feel, on design side to use your flange connections, and they just tend to be more reliable. And I think that anybody who's in the industry would tell you that. As far as the pumps, our vertical multi-stages all have the cartridge seals replacements, and I see if I can go back to that photo there. I can show you. So you've got your cartridge seal right in here in this section, and those are really easy to change. You don't have to remove the motor to change a cartridge seal. We can get you the parts fairly quickly. We stock most of that in our warehouse, and you can also get them from a local supplier if you needed there. But your vertical multi-stage pumps are obviously for your high rises that are probably over 10 stories. If you want to save cost, the customer wants to save cost, then, you know, we usually will line them up with an end suction unit. But the end suction pumps have their limitations. Sometimes they're more reliable because of the fact that they can carry more volume and there's not as many moving parts. But they're also limited on their head pressure. So if you're looking at, you know, something over 190 feet of head, we recommend, you know, switching up to the vertical multi-stage. And programming, talked a little bit about that. Here's some examples of some of our systems that we've built. You can see that a lot of these are out of the box. We kind of threw these in here just to show you that we get requests that are, not your standard units, and we can accommodate those people. But the one on the left-hand side, Kevin, where's that from? The big one with the
big one. So that's actually down in Cutter, New Mexico. That's an entire municipality pump station. It's
Okay.
actually Cutter is actually considered a ghost town. But yeah, that one was actually seismic rated with the anchor points and all that.
Okay, cool. Moving right along here. This is just kind of some before and afters of what you can do. I know that most of your guys' work is probably new construction. Occasionally, I know that Austin asks us for a replacement where he'll get into a situation where you've got a dated system and you need updates. Just to give you an example of some of the older style boosters, there's your old one, there's your new one, in terms of inside the panel there. We can pretty much, if you've got a job, you send us the original drawing or the original conditions. I mean, we get it. I'll be honest with you. If you're a good booster manufacturer, you should be able to size the system with no information. You should be able to go out, look at the building, get a fixture count, get a building height, get your suction pressure read, and you should be able to design a system for that building. And that's kind of where we are. We have done a number of older buildings in New York where the customer, really had no clue, what they needed in terms of a booster pump. And we broke it all down for them, and gave them a modernized system. So anyway, you can see down here, this is the older system and it's a newer system. We are just to get into, I know everybody likes to get into the tank or no tank discussion. Personally, Kevin and I are fans of using a hydropneumatic tank. There's a number of different reasons. Probably the most common is the fact that the pumps don't run as often. So if you have small pressure drops either on the weekend or during the evening, the pump actually doesn't have to kick on and start. You can use the existing supply in the tank, and it just gives you a longer life and a little bit more ease of use in terms of how often the pump system turns on and off. So we like to use them. That's our feel. We can basically build a system without it. It doesn't really matter. We have soft start mechanisms in our panels if we need it. So you're not running that pressure right up to the top of the building and it's slamming at the top of the pipe and then coming back down and causing a bunch of vibration in the building. But our feeling is that if you got room for a tank, put it in. And in New York, we actually have a lot of our tanks on the roof because that's just the way the old buildings were designed. If you've been to Manhattan lately, there's no room on the sidewalk for anything. So they've got to put those tanks. They don't have any room in the mechanical rooms for those tanks.
And rule of thumb, you always want to read where the tank is. So if the tank is at the pump station, we're going to read from the pump station. If the tank is on the roof, we want to actually have a transducer and a reading there. We actually have it built into our program. We can fix an issue that happens when you're reading at a pump station and have a tank on top, because at that point you're fighting gravity and the tank. So the pump's trying to push, but gravity and the tank are pushing against that. So you tend to get fluctuations, which we can fix. But the general rule is you always want to read wherever the tank is.
Yeah. All righty. This is Northern Illinois. This is 2 systems we just installed for them. And you can see that pretty nicely done there. They're using flex kits here.
Yeah, the one on the left was designed after the one on the right. These were Toshiba drives. We accommodated. They asked for so these were delivered about 6-8 months apart. So they asked for the keypads to be on the outside. So that's why they look a little bit different. But ultimately, once you open them, they look pretty much identical, just different horsepowers.
Some notable installs around the country: Nobu Hotel, Northern Illinois, Naperville Crossing, 60 West Erie in downtown Chicago, We've got the Azure in Brooklyn. I won't go through the whole list, but Tito's Vodka on your medical hospitals, which I know that you guys see a lot of right now out there in California. We've got NYU, First Avenue campus. How do you pronounce that? Maimonides in Brooklyn, and then Parker Jewish Hospital.
Maimonides.
Yeah, Maimonides, yeah. And on the hospital systems, I just say a couple comments. They're probably, the system where, we can really accommodate that customer. They have several needs. I know you guys have the seismic rated panels out there, which we can do. We also, can do 100% redundancy on each pump if that's what they need. And we can also do, the building controls to match up with whatever they have in there. But obviously in locations like a municipality or a hospital or a prison system, those are really systems where you can never really have a pump down. Our philosophy is, if you have a system like that, you want to go with 100% redundancy on each pump. At a minimum, I would go 70%. On your smaller locations, let's just say small buildings where it's not, a vital building of some sort, or it's not a municipality, then, obviously you can get away with a 50-50 split on your redundancy, and you can, lower your cost on your pumps. But in reality, I always say to people, our philosophy is have the best redundancy you can have at the beginning, because it's not, when you're going to have a problem. Every building at some point has a water problem of some issue, and you want to be able to have a backup system in your booster, that can provide for repair, and you don't have to shut the whole building down during that time period. So anyway, I don't know if you want to add anything to that, Kev.
No, business stuff.
All right, let's go to the eye level. So eye level is a unique product in that it's something that we invented, actually the owners invented, and they patented. And it's a program that basically is a step up from your normal HOA controls for sump and sewage. So obviously in your normal system, you got your rhombus panel, you got two, on-off lights and on-off switches, and the systems run, in sync with each other. With your eye level sump and sewage panel, we're actually giving you a control panel for your sump and sewage. There's several advantages. One being that no matter what size your sump pit is, we can walk up to our eye level panel, type in the depth of the panel in inches, and it automatically converts it over to percentages, and it will, you can literally set, without ever opening the sump pit, when your lead and lag pumps will start and stop, and where your alarm level is. I would say the greatest difference in a standard system on the eye level that isn't on a standard HOA panel is that we're using a level control transducer which hangs in the pit. So we eliminate the problem with floats, and that was the reason for the technology, because of the fact that there's just so many times where a plumbing contractor has to come out to a building. They have no idea why the sump and sewage is failing, because all they have is an HOA light there, and the customer's telling them they got water in their pump room. Well, they come down there, and lo and behold, they've got a jam on pump one. They've got to take the pit out, the pit cover off, dig in there, clean it up, and usually it's a float related incident. So that kind of eliminates about 70% of your service calls on your sump and sewage pits. So as you can see, it's got your standard components pretty similar to a booster system, other than it's got motor starters instead of drives. You still got your 4-inch HMI touchscreen, and you can you can do all your setting controls right from the touchscreen itself. Same components brand on the brands. We're using a Siemens PLC or HMI and PLC. If necessary, an ABB drive, but we're using the motor starters most times. And then the Saginaw metal enclosure. The metal is obviously a little bit more of an upgrade, but it lasts longer than a plastic. I mean, I don't know if you've ever seen some of the plastic sump and sewage controls, but they're pretty flimsy. We feel like this is a better situation for a larger building, and it also gives the plumber a lot of easy conveniences. For instance, on your top screen here, you could see that it's got your alarm, your fault reset. It shows you pump 1 or pump 2. And by the way, one of the things that's kind of neat on this is this actually tells you which pump is bad. So if you have to open the pit, it will tell you, hey, it's pump 1. So you don't have to dig down there, pull out both pumps and look at them both. You know exactly which one is in fault. If you're using this system in conjunction with our SCADA, we have a unique program on SCADA where this system will give you a readout on Wi-Fi, and we use our own connection. We're not using the building Wi-Fi. We're using Kevin, what's the control? I'm drawing a blank here for the Wi-Fi connection in the panel.
It's a cellular. It's a cellular modem. Connection. So it's a Verizon. It's a Verizon network. So, but it's not a general. It's not like a hotspot. It's only looking for our stuff. So no one can go in. You can't get hacked. TJ Maxx was hacked through the air conditioning unit. So it's very safe, and no one can pull it out of there and attach to their laptop and go. It won't work. It only works for our IP address.
Yeah. Okay. So anyway, it's a neat feature in that I can pull this screen up from my laptop or from a remote building control. And let's just say it's the weekend and you've got a building that has a problem with sump and sewage. Well, if you call your service guy, you can say, hey, listen, you're going to need a pump because I can see that pump 1 has failed on the screen. Now, if it's just an auto reset, you can try and reset it from your computer screen without ever going out to the location. If the system starts running again and the pump doesn't go down, then it's all done. You're done fixing your problem there. If it's a situation where the pump is actually out, it's going to tell you, hey, you got a pump out or you got a pump clogged, and you're going to need a service person to go out there at the location. So this is, we feel, the future of sump and sewage control. We think that down the road, we think the HOA lights and the HOA panel for the sump and sewage is going to go bye-bye. But, other than your really, really small locations where they don't want to spend the extra expense. But if you're a person who's designing a large project and, you've got 3 or 4 buildings, and you do have the SCADA control, and you also have some kind of a backnet or a Modbus connection to the main building control, this thing is ideal because it already speaks backnet and it's already set up to go. So if you have an HOA panel, obviously that's not going to happen. On your clogs, just one more note. Sometimes it's a 5-second deal. I mean, it's just something got jammed up in there, and it's just trying to suck through the pump itself. When the fault goes out and the pump stops, now that whatever that piece of debris is falls out, and then you go hit your reset and you're back in business. So we feel that there's just a lot of conveniences. I mean, especially you consider today with the COVID situation, people not wanting to go into buildings at times, or let's just say a building management company doesn't really want anybody in the building. This is an advantage to all those situations. So we feel like it's something that we'd love to get out there and maybe do a meeting or 2 in person with you guys when we can come down and just show you the system itself. I have a demo unit that I can bring out and show you how it works, and it's pretty simple to understand, and I think you guys might want it on your higher end buildings. On technology on HOA versus PLC, obviously, kind of went into that. Your adjustments are much easier. What pump failed gives you an idea. And like I said, if you have a remote control access through SCADA or BMS, the PLC gives you the ability to do that. And we feel like that's a leg up from the standard HOA system. Here's some nasty looking floats that we took pictures of to show you why we use a transducer. Transducer just hangs in the bottom of the pit, and doesn't have to be adjusted. You set the limit and you put the amount of inches depth. I mean, one of the ones that we just did, which was crazy, we had a sump pit in the Hancock Tower in Chicago that was only 2 feet deep, and there was no way to put a float system in there. And when we told them about the level control, we dropped it in there, put the eye level system in there, problem solved. And don't ask me why they only built a 2 foot deep sump pit. I don't know, but that was the issue, and we solved it for them, and the eye level came in handy there. And, I just would add that there are other systems that do similar things out there for many, many thousands of dollars extra through other manufacturers. We feel like we've got this down to, where this is doable for many building sizes and many projects that are, as you guys know, you're always looking at saving costs. So this is a way to save cost. I don't know. I don't see any questions. Austin, do you have any questions or anything you want to add to the presentation here?
No, I don't see any questions either. Nothing in particular I wanted to add it. I was going to mention something about those hydropneumatic tanks, but you guys pretty much covered it. A lot of the time what we see on those hydropneumatic tanks is just for ease, it's typically installed right next to the booster, which is on, ground level kind of situation. But,
right.
There's a pretty easy way to save money when you can is definitely putting that on the top of the building. Kind of uses gravity to add additional boost or take up some of the boost that's required in the building as well. You can also save cost on the size of that hydropneumatic tank as well, reducing
size
the size
and pressure.
That's right. Yeah.
Building, you don't need a high pressure 250, 300 psi. You can go down to a 125. And that's going to be a significant pricing decrease.
Yes, dramatic. You could easily save. Depending on the size, you could save anywhere between like $3,000 to $8,000 sometimes. It depends, but it's something to kind of look at in your designs. Yeah, something to look at in your designs. But yeah, if there is any questions, feel free to ask them now or get in contact with myself or the DB sales team. Mike, Kevin, thank you very much for presenting today on those advantages to the system. Very excited to get some, quite a few more of these systems out in California. We definitely do have a very unique market. I'm sure a lot of these engineers and contractors on the webinar today can attest to that. But thank you very much again.
Okay.
Yeah, I appreciate it. Thank you.
All right. Have a good weekend, folks.